Okay, great. So APS, does everyone know what those are? Kind of at the corners of intersections, the audible sounding devices that they basically give visually impaired users the same message that sighted users have as far as the walk, don't walk signs. We do have quite a few in the metro area. So we'll get into that with the details of accessible design. Before we get into that, just wanted to be fully honest and transparent. APS is not currently an ADA standard and is provided at the discretion of the Title II entity. Also, APS is recognized in the MUTCD, but engineering judgment factors into making a determination on whether or not to provide the accommodation. So those first two things make you wonder, so why are we even doing APS, right? It's not required, you don't have to do it. But we'll keep going down and say APS is recognized by the courts as a reasonable accommodation, and it's considered a best practice by the FHWA. And the Access Board, who makes the regulations, the standards, their position demonstrates APS is viewed as a reasonable accommodation for blind and low vision users, and APS will be included in the final rule for public right-of-way. So there's a few things going on there that actually MnDOT had a small complaint filed against us, but it did go to Washington Department of Justice and the St. Paul FHWA, and the basis of that was we were not doing APS. So visually impaired users rightfully said, you know, I don't know what this signal is telling me. It's not communicating the same language, the same information, so it's not accessible. And, you know, what could we say? It's a very hard case to say it's not, or say that it is accessible. So it was determined that we weren't going to win that. So part of the outcome of that was we just basically said we are going to make APS a standard as we do improvements. And actually that's where my position started in my unit. We started amping up our engineering side of accessibility, and this was in 2010. So also, where we said APS will include it in the final rule for public right-of-way, the Pro is actually a new version of ProAg. It's public right-of-way. And they've got language currently in Pro that says that you will need to upgrade APS as something as simple as a timing change, which would be a big difference. You know, you're not even doing construction. You're just doing signal timing change, and you do have to do APS. But when that switch gets flipped, that can be very drastic. So MnDOT actually wants to be more proactive than that. You know, we had the complaint, but also, and you know, we are leaders. We've got over 50% of our system that has APS on it with our pedestrian facilities. So we've worked with this a lot. But also, we want to control our own destiny and making sure we're doing things on our timeline. So as we're replacing new signals, that's a good time to do it. Or if we're upgrading curb ramps, that is also a good time to do it because you have all the underground in, your curb ramps are done, and you're just basically done. If you do the curb ramps first and you do the APS later, you end up reworking a lot of that work, and we'll show you some examples of that. So we think that's the most effective time to do it, and it is included in our transition plan to limit liability and risk. So a little bit of the background of the legal parts of APS. Now we'll get into the design portions, and from our experience, we think it's good to talk about designing the quadrant first. We'll talk about the MUTCD criteria that we have for that. We also have some MnDOT criteria we'll talk about, see how right-of-way fits into this, and crosswalks, talk about a plan format, and other elements such as pork chops and bump outs. So the first slide we have is a typical type intersection, and with APS installation. It's got two push buttons on it because there's two crossings. So you always want to have this outside push button is on the outside edge of the crosswalk here. Again, this one over here is on the outside edge as well, as you can see. So I use my hands here. But it's always off this outside edge. And so there's one push button for each crosswalk. And the push buttons always need to be adjacent to a landing. And that's so users in chairs can be on that relatively flat surface and activate the push button. The push button also needs to be 42 inches high. And that's actually just a MUTCD standard that's been there for quite a while. It's a traffic standard. ADA actually gives more flexibility. It says it can be anywhere from 15 to 48 inches. But in this case, consistency is important in a lot of things, and our standard is 42 inches from our traffic folks. Also, you need 10-foot minimum button separation. And that is so users who are coming up to the intersection, you've got the locator tones. These push buttons beep 24/7 just in the vicinity of the quadrant itself. And that's so visually impaired users come up here. And again, I've got one crosswalk for this leg and one crosswalk for this leg. So as you approach the intersection, you can, with that 10-foot distinction, oh, okay, that one's for this right crosswalk. This one on my left is for that left crosswalk. Having two push buttons on the same pole is very confusing for users. What is this one pointing me here? Where is this one supposed to be pointing me? So consistency is really important, and we'll talk about that. Keep hitting on that. Also, the push button needs to be no more than 5 foot offset from the edge of crosswalk. And that's because some users do depart from these push buttons. And if you're located over there away from the crosswalk and you depart from the push button, you need to be in the way of those queued vehicles. So again, users use them differently, but some users will depart from the button and they'll even line themselves up perpendicular with the sign and say, when the audible message comes, that's where I am going to go. And they're going to use that, square it up, and go with it. Other users will just leave from the tapers or the domes, but for the users that leave from the sign, it's really important to have where that location set. But I've been talking about visually impaired users quite a bit, but there's also another function to the APS, and that's the vibrotactile push button feature. And that is for users who are both deaf and blind. So again, they're not seeing the cues or even hearing the speaker, but they're sitting there at this push button waiting for it to vibrate. And when it vibrates, they will start their crossing and go across this roadway. And, I would still say that is courageous, crossing some of our high-speed roadways. But users are using them this way. So it's very important that we obviously design these things correctly. It takes a lot of faith, because that's what they're saying. You got to design them right. You got to build them right. They got to be maintained right. So they're counting on us as individuals to make that happen. So the details do matter. So then finally there's this push button setback. It's a minimum of 1.5 foot from back of curb. And the MUT talks about it should be up to 6 feet from back of curb, with exceptions up to 10. But MnDOT is using that full exception quite often because, again, we're in a snow and ice climate. So we're really trying to get this push button outside of the middle of our walks because of maintenance purposes. So we're going 1.5 to 10 feet maximum setback from the back of curb. There are other additional MnDOT requirements. Those were all MUT requirements, but now at MnDOT, basically whenever it's on an individual push button station, a push button, we want that to be a minimum of 4 foot from the back of curb. And that's just simply for knockdowns, overturning vehicles, snow plows, don't want those to get knocked down. So we want them to be at least 4 foot. When you do need to put a push button on the pole, as the picture on the right, that is fine to put it right there. This one's actually compliant. It's probably 1.5 foot from the back of curb, and that pole is not going to get knocked over, and so that works well. This is a tight corner. You weren't going to be able to do anything else on that area with that minimal par and whatnot. So using the push button on the pole is fine. So now that's a lot of criteria, right? I'm really limited where I'm going to put these things, and I want to meet all these standards, which we definitely want to do. But also, we don't want these push buttons to be in the middle of our sidewalk. So we've got areas, and when we'll talk about this, this has 2 grass boulevards on it. Whenever you can get grass boulevards or boulevards period for ADA, do it. It makes it so much easier. There's so many benefits. The design and construction is better. Just the pedestrian environment is better. So again, boulevards are huge. So when we have boulevards, we generally are able to favor our push buttons towards the front of walk. And again, that would be in that 6 foot sweet spot we talked earlier. But you can have a landing, a ramp and a landing and the push button all in line with this front edge of walk, which actually works real well. And again, same thing over on this right side with that in line with the front of the walk. It's a tough push there. So that works well in that type of situation. Now, when you've got a full width sidewalk, we generally favor the buttons towards that back of walk, just so buttons aren't in the middle of the way. If we put the push button, say, right here in the middle, can block things up. So we're trying to avoid that. And again, every intersection, the geometry is a little bit different. Here we have 2 individual ramps, which works great. But what I like to show here is on the right side, we've got a boulevard coming in, so we could favor the front side of that walk with that push button at, say, 6 feet back. This side on the left is a full width sidewalk, so we align the push button with the back of walk. So both fully meet standards, they're out of the way of the walk. The additional benefit of this is when you have this front to back stagger on, that actually helps you get that minimum 10-foot separation, which helps a lot sometimes. Again, if this was pushed more towards the back of walk, you'd have to widen it out to get that 10 foot of separation. So there's a lot of little tricks you can do, just knowing how to fit the criteria in. So we'll talk about maintenance access routes. Oh, question? Yes.
Quick question before we move on to maintenance. I was under the understanding that in addition to the push button location of 10 feet separation, all of that, that the push button is actually directed the direction that the crosswalk goes, so they can line up with the direction of the push button.
It does.
So, okay.
Yes, yes.
You either didn't mention it or I didn't
Okay.
mention it.
So yes, the users are getting the exact directionality out of this. It's lining up with where they're supposed to go, and that's what I was talking about, square it up with your arm or using your palm for the vibrotactile feature, and that is guiding you exactly where you're going to the other side.
So
Yep.
of all the design elements in the quadrants, push button would be best for giving directional location of the quadrant.
Yes, that signals, yeah. So it's really hard to make the ramps directional, I'll show you that. But the push button is a great technique for giving directionality for visually impaired users. Definitely, that's very important. I also should mention, there are some criteria. It's hard to get them all in sometimes. So the first one that MnDOT gives on is that separation. We'll bring it down to 8 feet sometimes, but we'll want to document why we're doing that. And then you can give more of the verbal message. The MUT does allow that for that configuration. And I also should say the push button is timed from the departure point, so where that location is. That's the start of your crosswalk timing, so it's 3.5 feet from that push button to that far curb line. So maintenance access routes. Like I said, you're not going to find this in ADA. It's not in ProAg. We just have it at MnDOT because we're in Minnesota and it snows. And it snows on all your corridors as well. So we think this is a very good practice to have. We want to make sure that our sidewalks can be mechanically removed with snow and ice. So we're wanting you to think about this as you're sitting in like a skid steer, for example, something that's 6 foot wide on a sidewalk to get a bucket through or a broom. So we want to follow the same route as the pedestrian access route because that's what we want to clear for snow and ice. But also you don't want to have restrictions less than that 6 foot type width. So that's a clear zone between like a button and a building, or a button and a sign, or a cabinet, or a pole, or a V-curb. Anything vertical that's going to not allow that broom or skid steer to get through, you want that to be clear. Notice I didn't say anything about the cross slope because that's more of a par thing. The maintenance guy doesn't care about cross slope really, the skid steer doesn't, so it's just following that same route, 6 foot clear. Also on trails, they're wider, they're maintained differently, so sometimes you have a plow on the front of a pickup, so those would be 8 to 10 foot wide maintenance access requirements. So you want to talk and make sure you're meeting your maintenance needs with your designs. Any questions on the PAR and the MAR, I'm sorry? Okay, so here shows a picture of, we definitely have that 6 foot clear from the edge of the T-base to the face of the building, so that's what we want. Here's the other thing that MnDOT added. If at all possible, we want 2 foot back from the top of ramp to put the push button. Now, all ProAg says is you need to be adjacent to a landing. So I can have that push button at the front of the landing, I can have it at the middle of the landing, and I can have it at the back of the landing. There's certain areas that are better for usability. Right in the middle is what I shoot for. So, for example, I'm a para and I've got pretty good strength, but I do have balance issues. So as I start reaching forward here to hit this push button at the front of the landing, I'm holding myself up with my hand here. And again, if this hand isn't here and I start reaching farther forward, I basically fall over because I don't have use of my legs. You guys are all using your legs to sit up right now. You might not know it, but that's what's holding you up. If If you don't have those, you'd have a lot of that balance issues. And again, there's other people with higher impairments with me that have a hard time even reaching forward or reaching even to where our button is. So having that centered is a very big usability thing. Also, as far as if the button, let's say this carpet is the back of walk, and that button is back here, right at the back of the walk, much harder reach here. You know, I'm torquing around pretty good, and I've got a lot of fusion going on here, so that's a hard reach. So again, if we could just add 2 more foot of sidewalk behind that, where this button would line up again and be centered on that landing, much better from a usability standpoint. So yes, that's MnDOT's 2 additions. And you know, something does have to give, we get that. So when push comes to shove, we're gonna use the maintenance access route over that centering it on the landing. But again, we can only have it 0.75 feet. I'll show you that in a minute because we have an integral base. So it's got to be that 9 inches minimum back from a landing. So I like to show this one. This is an older project. So how many people like the installation on the left side, the picture on the left? Right? No, not too many. How about the one on the right? Some nods. Yep, people are liking that one better. Do you think the one on the left is compliant? Yep, it is. So this is where we go by when you can, if you just want to go to the minimums and build things compliant, you can end up with some dumb stuff like this on the left. And that's what we don't want for obvious reasons. And I'll kind of tell you the story here. The design actually called for this push button to be more where the barrel is, but there was a conduit underneath here. So the contractor decided, well, that's a lot of work to move that conduit. I can just slide this push button back out of the way and it's easy, still meet standards, so everyone's good, right? Yeah, no. Not what we wanted, but more than that, I mean, the business folks here in the community said, you know, what are you doing? You just ruined our sidewalk. And our answer is, our project team, well, it's compliant. You know, does that matter to all the other users? I mean, that's right in the middle of the walk. You talk about maintenance, not going to happen. 2 people walking down the sidewalk, it's a hazard. A kid on a bike, whatever. So actually, we went back, had the contractor put the push button where it was supposed to be. He dug around the conduits, got that 6 foot clear, you know, got a wide 6 foot pedestrian access route. So you got your MAR, you got a wider PAR, more usable, still meet standards. So again, both of these do, but obviously one gets you better results than the other. So don't always dial down to the minimums. So we've talked about how to put all the plans, the quadrants together. Now we want to show how it goes into a plan set. So this is one of your example sheets that you have. You've got a plan sheet for this. But basically this talks about where to put the push buttons on the landing. And this one on the left, the one on the right is, has a 2 foot setback and a 6 foot behind it. So basically that's what our landing table talks about. 2 foot to the front, 6 foot to the back of the landing. So we're describing this for a contractor so he knows how to build these landings. And I should have even backed out a little farther, because before we used to have signal plans that were basically schematics, and it was just like field people, go locate your signal components wherever it is. It rarely worked out with ADA. So we're starting to detail these together. So we've got the same push button nomenclature for that as a signal phasing. We've got XY coordinates for the new signal components, because there's always, you know, a question if MnDOT says mark it here, someone marks it here. You know, we want to have that record of where it is, and we want to have it thought out of where that pole should be. There is an example of where it says on pole for an existing pole. We're not giving coordinates for that, because that's obviously going to stay where it is on an existing pole. But then we are also describing all those XY coordinates in this landing table. And that's what I was getting at push button 6.1. You can see there, you've got the 2 foot from the front of the landing, 6.5 foot to the back, so you get that 6 foot maintenance access route, so you're good. The push button on the left, PB82, it's the end of the sidewalk, so just 2 foot to the front, 2 foot to the back, centered on a landing, very, very understandable. I would like to mention though, if you're ever going to extend sidewalk in the future to on that left side, you're probably going to end up reworking that landing. So know what your whole configuration is if you want to avoid that rework. Even more important than that sometimes, if you only put in like one crossing or one push button and you want to put this other one in later, you're obviously always going to have to build that other quadrant. But even that quadrant you came from going from one push button to two push buttons is quite often going to need to get reconstructed because you have a different set of constraints. So think of what your whole system is as you're designing these. So here's a picture of what a contractor did. We called for a 4-foot long ramp with the button centered on the landing. Contractor built a 6-foot ramp. It was clear it wasn't what the plans called for, so that one was rebuilt. So there's a lot of things at a quadrant, especially a signalized quadrant. The first being, you've got the turning radius that's minimizing your space, and that's where your cabinets are, your poles. I'm talking push buttons, but you've got hydrants, signs, curb ramps, so a lot of stuff. So we're saying often you need to get more room, period. So we're using these types of footprints. We had been using it in our detail design because we hadn't been designing them out far enough to allow the right-of-way process. We're using these as footprints for the pre-design. But also, even in our scoping process, we're using these now. So we want to make sure that we're starting at this outside 0 and going back 15 feet to, in this configuration, we've got the push buttons at the front of walk. So again, we're about 6 feet back. Get a good 6-7 feet behind that. Get that permanent right-of-way. So you've got the footprint you need to get these buttons in here. There's another setup where you've got the push buttons favoring the back of walk, 10 feet, add 2, so you're at 12 foot, permanent right-of-way. And again, always get that extra 5 foot of TE for construction purposes. But again, these footprints are often too small to get all this to work. So we're starting to acquire that on our projects. I like to show this one. This actually is real common anywhere you go, but see anything wrong with this picture? Yeah, there's a few things. And actually, I'm not even really getting into APS right now. I'm just talking just traffic design and pedestrian design. But this is a 10-foot wide trail, so I'll get into the obvious part. Well, the obvious part's the pole in the middle. But even to start on that, you only got 6-foot wide domes. Should be the full width of the trail. And again, this isn't APS. That's actually just a solid state push button on a pole, and then the big mast pole in the middle. But all kinds of issues with this, and this is near my home. So I'm on a hand cycle going through here, and my biggest fear is not the left turning cars or the right turning cars are going to conflict with me. It's how am I going to get through that maze on the other side, where we're lining up all these obstacles and my bike doesn't steer too well. But I'm not saying you have to design it for me on my hand cycle, but that same thing is there for like little kids on bikes weaving through here. Visually impaired users, not good. But the obvious thing, how is this ever going to get maintained? You're going to have your plow truck coming down the other side, your pickup, 8 to 10 foot wide. He gets here, jump the curb, get out your shovel and shovel this area? No, neither one of those are going to happen, too likely. So even if you're not doing APS, strategically think about what we're doing for the future here and why that needs to be in the middle. And again, I could go through these all day. This is near my home as well. Brand new signal installation, signal pole right in the middle of that landing, top of the ramp. Again, I think you do have 4 foot around it, and it's compliant. But again, I've got this hydrant over here in this back of the berm. Why can't that signal pole be right over here as well? Just out of the equation and just let the pedestrian system be what it is, maintainable, usable, and whatnot. So again, it's a really easy change there. This one is actually on MnDOT right away, and we've got a lot of these. We're trying to put 2 push buttons how we want it. But again, this thing isn't probably even compliant because I don't think we have a 4 foot par in front of that. And again, not usable at all. So we're adding sidewalk to the right on a future project. So part of the cost of doing business, we're going to relocate this pole. 15 grand, move on, kind of fix some of our past mistakes because it's not a good pedestrian network. Yeah, there you go. I really like to show this one. And this one actually is pretty frustrating because this is a brand new signal and we're still doing it. And we've got this 10 foot wide sidewalk coming in, colored concrete, nice. We're pinched down to a 4 foot par in front. That's the accessible route from an accessibility standpoint. But even bigger than that, people say, oh, these extra push buttons are clutter. How is this not clutter? This is like a white picket fence lining things up. No one can get through here. There's no reason that pole could have been over here in the grass, just out of the equation. But again, we like to put our signal poles in the middle where we have our heads and whatnot. A lot of past practice that we need to think about. So I've talked a lot about pole locations, and here actually the pole was done real well. It was placed out of the way, upstream. This is tricky. Upstream, out of the way. Again, the push buttons, you had a par in front of them. It's that footprint I was talking about. We acquired the right-of-way. But no one thought about where the cabinet was going to go. And our cabinets are huge. They're 9 foot by 4 by 5 feet tall, big. So we would have had, say, an 8-foot sidewalk or more, 8 to 10 maybe. Again, this cabinet gets plunked in here. Boom. I'm down to 4.5-foot pinch point right there. So again, I'm not going to be able to maintain this. It's not even that, it's a tight area. And actually, the city engineer talked to me about where that shadow is actually in a north-facing area. So that's iced all the time, all winter. There's a lot of 18-wheelers coming around this corner. So again, even other hazards that you might not even think about. So, but even more important than all of that, what really gets me on this one is if you start looking at the lower part of this picture. Now, if I'm in a vehicle coming up to this intersection and I'm going to make a right turn, I'm looking left quite a bit because that's where I'm going to merge with cars, look for hazards. I might glance right, but I'm looking left. I'm coming up here, seeing here. But that whole time I'm coming up to the intersection, all I see is that cabinet. And that's exactly where that push button is, behind that cabinet. So I have no idea there's a ped there attempting to cross. The ped probably doesn't see me too well. He or she may be taking a step out, 1 or 2, and it's like, bam. Bad deal. It's a brand new signal. It's going to be here for 50 years, and hopefully nothing happens. But a lot of short-sightedness in this. And again, this is ADA, but it's beyond ADA. But obviously, ADA users are more vulnerable. But all users, this is obviously we haven't been thought through all the ramifications of some of the designs we've been doing in installations. And now looking at hindsight, this area over here, we bought the footprint I was talking about, but there's this area over here, this remnant area. We already acquired right away. That would have been a perfect spot to put that cabinet downstream. Again, that's not even a parking area. It's kind of a remnant piece. So ideal location would have been that in hindsight. So we'll start talking about how to put together in a plan set. We've got the control points. We had the signal components with XYs, also the control points. And these are kind of the working areas, these red dots. It's all on the outside edge of crosswalks as you go around the intersection. We're also pulling medians back, median noses, so you have that straight path of travel. And so we're putting XY on all those. And a little tidbit, we don't put 2 XYs on radial domes because they can be bought by different suppliers and their cord lengths are different, so that cord length can vary. We're just putting in there within the nearest foot to our plans. Contractor would field fit the actual curb tapers in the 0 locations. So again, that is an example plan. You have the handout of this. This is on our website. It's basically how we've been doing signals for the past 5-6 years. This is that coordination drawing, 20 scale, hopefully if it all fits, maybe 30 scale. But everything we talked about is on that plan. So that is required whenever you're doing ped ramps at a signalized intersection and APS on MnDOT right-of-way. And this picture shows a good example. Push buttons out of the way, pole out of the way, cabinet out of the way. Handholds are also out of the way. So we're telling where to put those on the plan so contractors know. Often the first person there is the guy on the directional boring unit, and he'll just go in here and say, this looks like a good spot. He'll pick the worst area, the prime location that'll change the whole design, and you're scrambling from that point. So again, show where to put the handholds so they know where the good locations are. So here's a design, maybe a dreaded red line that comes into our office. This is a signalized intersection. And my first glance, even when I start looking at this, I see this perfect box of the crosswalks. Well, that's probably not our highest concern. Again, the engineers like it square, but there's a lot of other criteria ahead of that I'm going to talk about. The first being is where even the potentially skewing the crosswalks. For example, this one, we want to keep that pretty well up to the close to the intersection because that's where vehicles stop. That's the stopping side. It's really critical where cars stop so they can see both ways and see their area. Again, if we move this crosswalk too far back, vehicles will pull onto it. This is what I call the downstream crosswalk over here. A lot more flexibility. There's not vehicle stopping here. So I can float this one and get more separation for that area. So again, we did that in this upper area as well. We held this side over here for the stopping side, floated this side over there, the downstream side around the corner. So we'll blow it up a little farther and talk about what some of our recommendations were. This picture came in, and it called for an S fan with a catch basin in the middle, but more important than that, there's this push button here that is right at the front of the lock, what we talked about, but it's at the top of a 3-foot ramp. So it's within that 4-foot area where things are going to get knocked down, but it's also not centered on a landing. So if we did that, it'd be in the middle of the walk. But basically we're saying, well, let's try this one at the back of walk. Lining up, it'll still meet good standards there. Once we move that one to the back of walk, we're too close between this and that other push button. So we actually move this push button up to the front of the walk, and by extending these domes, maybe 4 foot, we're able to find a 6-foot boulevard area, so a 3-foot ramp, 5 to 6 foot push button. So able to get more room to put that push button. So again, it works real well. It's outside of the sidewalk and it meets all the push button requirements. Also, this big, large signal pole is likely real close and could get into problems because when you're constructing the base, these things are 12 feet deep, 3-foot diameter, and again, our utility locates are kind of iffy. You don't really know until you're in the field where the things are, and so often that can really screw up our design. So we're playing the odds here. Let's get this big signal pole out of the way. Just shift it in line with traffic so it's the same mast arm length. Get it out of the ramp area. We already had right of way here. And if this thing moves 2 or 3 or 4 feet, it's not going to affect your ADA design. And the traffic folks will just worry what they have to figure in. So again, a lot of variables here. And you can see why it's kind of an iterative process because I've probably listed 10 different APS criteria at this point. So what is frustrating is this came in at 90% and we had it all figured out finally after the iterations. But the design came in at 100% and the sidewalk that used to be here was now at back of curb. It's like, oh, come on. Basically, we're starting over. You've got a new set of constraints, a new set of assumptions, so you can start that whole process over again, which would obviously be frustrating for the designer, frustrating for us as well, but even the designers don't always understand that. But there's an interplay of all these criteria. So looking at this intersection, it's an older intersection. We installed this push button correctly within 5 foot of this outside edge of crosswalk. We had our 10-foot separation, which is good, but when your two crosswalks are on top of each other out there in the middle of the road, you're generally not going to get it all to work because you're going to start exceeding this last 5-foot area, the 5-foot setback. So again, we could have moved this crosswalk back here, but that's the stopping side where vehicles are, and we want to keep this one generally closer. So we think it would be better to shift these buttons this way, and again, move this downstream crosswalk where you get that more balanced, effect without impacting the traffic stopping area, the vehicle stopping area. So we like to show this one. This was actually designed good because they brought the median back. I don't know why the contractor insisted on putting the kink in there. Shouldn't have. But even there's designs that come in that actually don't pull the median back. So that median is out there where that pointed area is. So you don't want to do that. Because if you're a user, starting from this 0 point, you leave from a push button, we're telling them to go directly across, you're going to have a trip hazard. So that's why you got to bring it back. But if we wanted to point them, along this kinked crosswalk, obviously that's not good. There's no way to correct on that kink. So you're just taking off to the middle of the intersection again, or into those other lanes of traffic. So again, we always want our crosswalks to be straight. They don't necessarily have to be perpendicular. That doesn't matter. If a user's on a push button, they don't care if they're going true north or 3 degrees over, whatever works. But again, you don't want kinks, especially these inward kinks, because there's no way to correct from them. Sometimes we will do an outward kink away from the intersection if you can land in a median and at a push button that allow you to change direction. So some of the finer points there, but those are huge things to start your design with, some huge assumptions. So this is an intersection that actually Annie was talking about in the earlier video. And we were able to do some good best practices for her. and we grooved these outside edges of crosswalks, and basically this is just pavement striping grooving without the striping. So again, she can use her cane and get right across that. We also did that in between the curb ramps so she could have better wayfinding. Previously, she navigated around the circumference of the perimeter of the pork chop because that's where she found the curb line to find the next curb ramp. So this is, again, a much better, very simple type improvement. And this would work good at non-signalized intersections as well, skewed intersections where it's hard to have that direction of travel. So we actually offered this to, we had a project down by the school for the blind in Faribault, and they had one of those tough non-signalized corners, and we said, we could make this a lot easier, where we could groove this stripe in here, you could track it across the intersection, end up right where you want. And it was a little interesting, but I get it. They said, nope, we don't want that because that would be too easy. Go do that everywhere else, make it a standard because that's what we have to deal with every day. Don't make it too easy for us now because we have to learn how to deal the hard way, everything that we've built for them up to this point. So kind of interesting thought. And even some of these practices, this grooving is pretty simple. A lot of times we'll say we want to do like V-curb and channelize things, which again is harder to design, harder to construct, harder to maintain. So some of these low-cost ideas, I think have a lot of potential. Actually, I think.
What's maintenance like? I mean, snowplows aren't catching them or anything?
No, the maintenance. This is just a simple. It's just like pavement striping. So it's the same thing if you had a crosswalk grooved or anything else. So yeah, nothing. Yep. So talking about pork chop size makes a difference as well. We use a lot of 4-inch curbs at pork chops because that reduces theoretically the ramp length by 2 feet already versus a 6-inch curb. But we also want to have good footprints in here. So these red lines, shows where you've got a 4-foot ramp, a 4-foot landing, another 4-foot ramp. You need a minimum of say 12 feet there in all those red line areas. So that's a good sized pork chop in the picture over there to accomplish what we're talking about. But the alignment of the ramps is also very important. The one on the left is pretty logical because all 3 of the middle of the ramps come to one center point. So it's real intuitive where to walk and even for maintenance. This one on the right, there were some utilities in the way, but it required a signal pole actually, but it required these curb ramps to be offset. So again, this curb ramp comes into the side of this curb ramp comes into the side of this push button. So again, doesn't flow at all well. And to kind of illustrate this a little more, here's an existing signal that was built, fairly new I guess, and they had to get 3 push buttons on here, so it was a little more complicated, but they decided to do this cut through with V-curb on the sides, and even in this side, we've got a 6-inch curb coming up here, so we're tapering down. Not even sure if that's compliant because you might lose your par in this area, but again, lot of drawbacks here. Like I said, trip hazards, maintenance, filling in with debris, snow and ice. But again, look where that crosswalk location is over there where that striping is. I contend there's no reason that striping needs to be there. If you just decided to move that crosswalk 6 feet up where these ramps could be more centered, all coming together, it's equilateral. I've got 4 foot everywhere now. I can come to a common landing and everything works really good. I don't have the V-curb and all that. So just a simple location change of one curb ramp can change it significantly. And again, to be honest, there is a 3rd push button here. So to get this one at a landing, we likely would have actually had to make this 2 foot bigger on this side to be part of that push button. So again, geometry and location both matter. Here is a rural area, a rural designed area. And I will point out here how MnDOT is approaching, people are asking, well, or you're thinking, why is there push buttons here? There's no sidewalk, where are you going, right? So again, this is a bigger pedestrian issue. It's not really ADA, but just upstream of this treed area, there's a housing development. So a lot of destinations up there, people coming and going, and we understand it's missing the sidewalk. It's not a fully built sidewalk, but there's still a need for people to come here. People still will go there. They still will cross our highways. So we want to make sure if there's destinations that we're meeting those pedestrian needs. And once the crosswalk locations have been determined, we want to make sure they're accessible from an ADA standpoint. Because Sometimes the biggest barrier is just crossing our highways, for sure. Because, a lot of you folks will navigate up the grass boulevard. I'll navigate up the shoulder, whatever. I mean, I'll get there. But again, the highways are difficult and dangerous. And even sometimes, when we've got a wide highway and we just rely on vehicle time, sometimes like the minimum green time is like 12 seconds. You are not going to get across that intersection in 12 seconds. So just having that pedestrian phase is important as well. So again, that's the pedestrian side of things. But from ADA standpoint, this is all a rural intersection, no curb and gutter, all sheds off at 1.5% or 2%. So we're doing that same thing with the curb ramp, shedding it off at 1.5%, not changing any drainage patterns. We've got the full detectable edge that Tim was talking about, full domes set back a foot. So you're going to hit grass, domes, or dirt or grass on the other side. So you've got that fully compliant. We are recommending that these push buttons be back a little further, maybe 6 to 8 feet because of those knockdown type reasons. But very simple design though to fit into those environments. Yes?
What about situations where there is no crossing? There are signs that say no pedestrian crossing. What's the indication to the person that's having trouble seeing to see the sign that says no crossing? Or you get to an intersection where it's got 4 of them, where you can't cross any direction.
Right, you're hitting a nerve with the no ped crossing signs. Again, it's a pedestrian type issue. You really can't communicate that language to visually impaired users.
There's no way of communicating.
But yeah, that's a big topic between the pedestrian folks and the traffic folks. Where should there be crossings? Where is it safe? I will throw in, I think engineers can be very, obviously safety conscious, but from a disability standpoint, I often think they're like maternalistic or paternalistic, wanting to take care of everyone and be safe. I'm more on the side of, give people the opportunity to cross, let them determine where it's safe. But yes, allowing more access instead of restricting it with signs. Yep. But there is always the place for signs. We get that. But for an intersection doesn't seem realistic. It's legal to cross there. How else are you going to do that until we put these signs up there and then we feel all safe about it? People still cross there. Yes.
Since you're going to have the grass boulevard right next to where that APS push button is,
Yep.
preference to carry the concrete a little further so that the users using the APS is directional. They're not
Yep.
crossing from the concrete to grass.
Yep, we're starting to do that, extending our domes so you've got that full concrete width in the crossing area. Just like that walkable flare would have been, but yes, extending your domes would help that as well. Yep. So here's the median type application, a rural median again. We've got our buttons on the outside edge of crosswalk, like we talked about, and we have a median push button station here, and that's just so, users who are slow, they can't keep up with the 3.5 feet per second, they may get stranded, or users who start late, for sure can get stranded, so you want to have that pedestrian call. So we're going to put a push button out there at a landing. Turns out this whole thing is landing. That's what the design shows for over there, because these 2 PIs are totally flat. So that's easy. You do also want to make sure, probably the trickiest thing is, what is your intersection drainage doing here? So you want to make sure that it's likely coming right through the middle here if this is all flat, but make sure it's paved correctly, because these are always bird baths in the spring, often bird baths in the spring and summer and whatnot. So you want to have drainage. There are times where the one PI is much higher than the other, so you might have a negative ramp to a landing to a ramp, and your drainage would come around the bottom side. So make sure you're figuring out drainage at these median intersections where you have no curb and gutter. Here, we hinted at this earlier, but this is a good install, but it's APS with directional ramps. And everybody wants to do that, and I'm fine with it. It's good if it works, but it takes a lot to get this to work. I like to show this one. To get a directional ramp here on this 6 foot wide, needed about 3 foot of directional curb. Then we've got about a 4 foot ramp. The button 2 feet back from that, we're at 9 feet. That's kind of that 349 I was talking about, but this one's actually directional. But anyways, we're back at 9 feet. We haven't had the par come through here yet. And we start talking about a 6 foot par behind here as a kind of a minimum. Now I'm at 15 feet. That's a wide sidewalk. We don't have a lot of 15 foot sidewalks. So if you want to get directional ramps with APS, quite often do bump outs like shown here. That'll allow that to happen. Again, the sidewalk lines up well behind both push buttons. I also like to point out, if you didn't do that bump out, if you just had 6 foot ramps here with a push button over there, and at the edge of this landing, you will never get 10 foot of separation on a 6x6 landing. So you need those to be separated apart. So that's another reason it's hard to have directional ramps with APS. But it can be done, and it can be done well. Here's an example of where we did curb ramp upgrades in 2010. Again, we ignored the signal. We were just making this as a non-signalized crossing from an accessibility standpoint, no APS. So we built these combined directionals. Now it's time to replace the signal. So obviously these ramps aren't going to work with push buttons. Again, the locations, you won't have separation. And again, even if we wanted to get the conduits in, you got to rip them up. So we're coming back and rebuilding, installing a new signal. And again, we've got a bank area where we got to tie into, so that's going to be a doorway match. Here's a picture. We did a lot of bump outs here. The city kind of wanted to go with a larger bump outs. We'll look at one corner in particular. Here is full 6-foot bump out, tangents in front of the ramps through the flare, compound radii, but a real good design. All landing areas, push buttons met the requirements. So real good design. Here's the after. Again, you get the full directional PARs and MARs and push buttons, the push buttons on the pole in the good location there, matched into the landing. So it actually worked really good. But these designs look a lot different than those non-signalized designs. So APS ramps are going to be different criteria. And there isn't a lot of actually national guidance on that. You know, like I said, there's a lot of guidance on how to do APS, a lot of guidance on how to do curb ramps. There's not a lot about how they fit together. So we've done a lot on that as an agency. So I'll go through a few other things that the traffic office has worked with us on. Made a lot of really nice improvements that makes this task easier. So a little bit of a history lesson on our push button stations. We used to have this detail, which was a precast base that the contractor would just kind of rough in the conduit, guess on an elevation, and it was supposed to be within 1/4 inch of the sidewalk. Never happened. So we started to modify that and said, well, no, you have to use a sonotube. So rough in the conduit, have a sonotube there for that foundation, pour your sidewalk, and then cut your sonotube off, pour your foundation second, so you know it would be flush. So I'm going to talk about that a little later, but that's part of the evolution. And again, this is where we were guessing wrong, you know, trip hazards and whatnot. We were also getting some issues here with differential settlement just between the foundation and the 6-inch walk, 12-inch deep foundation. So there'd be shifting here at different times of the year. So we wanted to come up with something better. And again, this is the new detail. You have a handout of it, and it shows our new push button on the left. I'll just also point out that criteria. This is on all plan sheets that have signals. It's got the MUT criteria, MnDOT criteria, how to locate the push buttons that we talked about earlier, landing table, and details on how to finish off the foundation at the edge of walks. But we'll look at this signal, the detail for the left. Here is where, instead of having a separate base, it's integral. So we have an 18-inch diameter, 12-inch deep, thickened sidewalk, tapered out, and we are epoxy anchoring in 4 bolts, and that's our foundation. So it's an integral piece, works really good. It's obviously always flush, less coordination between the contractors. So it's really sleek design. Again, we used to have bases that were 2x2s, concrete sticking out. Some agencies did. It was really hard to get ADA. So this is a much sleeker base that fits into these tighter areas. And maintenance likes this a lot as well. They break where they're supposed to. Before, right on the T-base, before it used to break into the concrete foundation. Electricians don't like doing concrete, especially in January in Minnesota. So again, very nice improvement. So maintenance is liking this a lot. And yeah, so it's working well. So that's that 9-inch diameter, 18-inch diameter, 9-inch radius. You want that thickened edge. So if you're at the edge of the walk, you would thicken around the outside. There's 2 different details on how to do that. Also, when you're even inside the walk, you don't want those joints to be anywhere in that 9-inch radius. So you want to make sure all cold joints or even saw cuts, any contraction joints, are outside of that radius. So again, that shows this detail on how to do that. And some of the devices that we had, before you know, we'd put the push button on a signal pole, and there were some limitations to that. Because we have octagonal signal poles, and again, we're supposed to direct people exactly where to go. but our poles are like 0, 22.5, or 45. So we had to find a way to start shimming that to get a little bit better direction. Also, there's a 10-inch maximum horizontal reach to reach the push button. And if I'm up at the edge of the foundation and we put it on the signal pole, we were right at 9.5 inches. So we were compliant, but starting to be at the edge of it. Now in Minnesota, you throw that snowbank there, and now you're like 19.5 inches, real easy. So again, it doesn't meet standards. So we're seeing what can we do to make that more usable and reachable. Also, there's that 42-inch button height we talked about earlier. So again, getting that height consistent. So there's some challenges. We came up with this pole mounting adapter, which works very well. We are able, on the picture on the right, we're able to tap into this round tube to get the directionality we want. It shims it out a few inches, so, about 6 inches, so you're less than 2 inches, actually, from the edge of the foundation. Also, you can adjust the height on it. Before, to be 42 inches, you would be bolting right into that flange. Can't do that. We also, Miller-Burn won't let us tie into the T-base, so we're really restricted. So before, this foundation actually had to project 6 inches for traffic standards, but no more than 8 inches for ADA standards. And again, this big thing was hogged in before any sidewalk was in and maybe even curb was in. So it was really hard for a contractor to figure that out. This adapter gives a lot more freedom for that. So a really nice innovation working with our traffic office. Also, pedestals, same thing. Reach distance gets violated. This is a 30-inch diameter foundation, 4-inch pole. So we're always over 10 inches if this is projecting. So we have a saddle mount adapter, this 2.5-inch shim on your right. You see the 3 things over here, 2 for the bolts, 1 for the wire. Shimming that out so it is in line with the face of the T-base, so which reduces reach distance. And a couple details in our plans that show you how to mount those on either the pedestal or the signal pole, either of those adapters. The pedestal base is important as well. So this was always supposed to be within a 1/4 inch flush in this detail off to the right. And that is because of traffic standards. Our bolts project 3 3/4 inch. NCHRP says you shouldn't have more than a 4-inch projection on a breakaway pedestal like ours. And that's so you don't want gas tanks to puncture, more likely to erupt. So it was always supposed to be within a 1/4 inch flush with the walk. That rarely happened. But it also was supposed to be that reason for ADA. So it's flush with that walk. So now we're saying, yes, it's good for traffic, but also good for ADA. So start doing that sonotube trick I talked about, roughing in your conduits, pouring your walk, strike your sonotube off, pour your foundation second. So again, you'll always get it flush when you use that method. And that is what this picture is showing here. A flush installation works really good. This one, not as much. Signal contractor might not have known what we were building. You know, we were building a cut through here, and so it doesn't even come close to that 10-inch reach requirement. But also, you know, from the contractor side, he had to keep this signal operational just during construction, just for vehicle phasing. So he sort of had to get this signal in here. He guessed wrong. And again, I think did a slight modification, but you kind of live with it, because what do? You know, how much do you rework and everything? So we want to set ourselves up to be more successful. So we are requiring contractors to have temporary type pedestals on donuts. Get those out of the equation for that week that the quadrant is getting built. Build your quadrant correctly, and then get rid of the temporary signal. So again, we should be putting that in our plan sets if we want our contractors to be more successful as well, and us. So the last slide I have is talking about RRFBs. And they are basically, the interim approval did go away from these in December. It now came back in March, so they're able to be installed again on MnDOT right away, on actually Minnesota right away. Minnesota got the approval. So we do want to make sure that these push buttons meet all of the requirements of accessibility. So we're saying it's the dimensional requirements of APS and also the audible message that says yellow lights are flashing, should be spoken twice. So we want to make sure any devices on MnDOT right-of-way are accessible. Recommend you do the same. A little bit interesting, they say that you should not use vibrotactile indications, which seems odd to me. I got to follow up on that one a little more, because again, it's not giving that information to deaf-blind users, but they say we're not supposed to use vibrotactile. But, so there can be different characteristics depending on the devices. But basically, if it's a push button actuated device, RFB or other lighted LED sign, that it needs to be accessible on MnDOT right away. I did forget to mention one thing. I said I was going to talk about Annie's politics. And remember that grooved intersection is the one Annie was at? But, and in the video, you saw that she had APS out there. And so that wasn't really the problem. She could cross the main 4 legs of the intersection. Where her difficulties were, where she was losing her 2 canes in the cars, was actually at the free right. So it's an obtuse free right, high speed movements. You know, they're supposed to yield, obviously, and she's at the curb, stepping out, and boom, there it goes. So obviously a precarious situation. And, you know, she's saying, yes, something can be done. But, you know, but what, you know, kind of MnDOT's role, or, you know, just in the engineering role, will say, well, we don't signalize free rights. That's what they are. They're free rights. They're uncontrolled. You're supposed to yield. So we don't do anything there. And she's asking, well, what can you do? You know, obviously that's not, she wants something to help her out. Again, that's how she navigates anywhere she goes. She goes to that bus stop. So, you know, so we ask, what can we do? Well, could we put a crosswalk there? Well, MnDOT doesn't stripe it because, you know, that's cost. You know, signage, we don't do that either. That's cost and maintenance. Also, is there something we could do to slow traffic? You know, would you put a raised crosswalk in, like maybe was mentioned back here earlier from Nicollet Mall? Well, maintenance doesn't like that, for sure. It's hard to plow against. Do we maybe bring the throat of that down, you know, so calm traffic? Well, no, you got to get the trucks through there. Do we do some striping to maybe just visually cue it down? Well, that's a lot of maintenance in the striping too. So, you know, we've got all kinds of reasons not to do things. You know, that's so we were challenging ourselves and kind of came up with the lowest common denominator, is what I'll say. You know, we couldn't do RFBs because that's not allowed, but we did lighted crosswalk signs with striping here in this case. And it's had a big improvement for her. But even it was interesting, our traffic folks only wanted us to do one lighted sign so it wouldn't interfere with the mainline traffic. And I was designing this, so I said, no, we're going to do 2. And if it's a problem, we'll deactivate 1. So, you know, we're looking for this lowest common denominator of anything that we can do. So, but again, we're very worried about setting precedents. So even if this works well, is this going to, we have to do this everywhere? And, you know, there are real costs to this, and maintenance costs, construction costs. And really the interesting thing was, or, you know, there's many interesting things, but even when it came down to it, it wasn't really just the request from Annie that was enough, but there was actually 2 visually impaired users there and a couple kids with wheelchairs. So, okay, that finally started to weight the scales where we could do some of this non-traditional, non-standard things. So, just kind of interesting. You know, that's what the outside sees and how we play our things and all of our functional units on what we can and can't do and what we do or don't think is important. So, some of the politics of just engineering. So that is actually all I have. Oh, I'm sorry. All I have for APS. Is there any? Well, I shouldn't ask questions because we're a little bit behind. We'll be available at lunch